Hello, students. Today we have a very exciting topic that we are going through in this video. More graphs of polynomials. We start this third unit with quadratic functions. Then we went to polynomial functions. And today we are doing more graph of polynomials. That is a very important assignment because we are putting together the three first assignments in this one. They're asking to us to graph now a polynomial. And they give to us this polynomial. They give to us f will be question number one. This assignment have only 4 questions, but are what is called essay question, means it's like 10 questions and 1 question. And the first question gives to us this polynomial f of x is equal to x squared times x minus 6. And first question, they're asking us to determine the end behavior of the graph of the function. I'll put here A, the end behavior of the graph. All right, what is the end behavior? I explained to you when we were going through the previous assignment, that we did this week, polynomial functions, that we need to find the end behavior. We need to make, first of all, one question to us. The first question is, what is the degree of the polynomial? And there is 2 ways that you can find the degree of this polynomial. First one, you have already that the first factor, because this is a polynomial in factor form, because you have one factor x squared be multiplied to a second factor x minus 6, and that is a product of a factorization. You have a polynomial, you factorize the polynomial, and that is the factors. And you can see the first factor is they have a second degree. And I explained to you that you have a second factor or a third factor, and they don't have any power by default, we can assume that is to the power of 1. And the only thing you have to do is add the 2 exponents. 2 plus 1 is equal 3. So you can say that the degree of this polynomial, you can say that the polynomial is degree 3. Why is important? Because second question that you need to ask to yourself, is 3 even or odd? But another way to find also the degree, another way to do it is you have the normal polynomial x squared, and you have the 2 factors x squared and x minus 6, and you use the law of this distribution for multiplication, and you distribute this x squared inside what is inside the parentheses. So you have a 1 as a coefficient, you have a 1 as a coefficient here, and you have a power of 1. So you can multiply 1 times 1 is a 1 or a x. And then because when we multiply polynomials, we add or multiply the terms of a polynomial, we add the powers. 2 plus 1 will be x to the third power. And then you multiply x squared times negative 6, and will be negative 6x squared. And again, if I show you this polynomial, x cubic minus 6x squared, and I ask the same question, what is the degree of this polynomial, you will look to which one is the greatest exponent. And of course, it's 3. So that is the two ways that you can find the degree of the polynomial. All right, again, why is so important? Because now you know it's an odd function. When you have an odd function, I'll put 2, you have two options. If the function is positive, and it's positive because in front of x cubic or in front of x squared, there is no a negative sign. So we can assume that there's a plus sign there and a plus sign there. No. So it's because it's positive, and that means the leading coefficient is positive, plus 1, plus 1. And that is called the leading coefficient test. You do the leading coefficient test and you find out that the leading coefficient is positive, then the function is positive. If you have a negative in front of the whole polynomial, that means the function is negative. All right, if it's an odd function, no, if it's an odd function and it's positive, we know that will rise in the right and will fall in the left. That is the end behavior, because this specific graph is a cubic graph. Always all the odd when we learned before when we were doing transformations, that all the odd and we were looking algebraically to know if a function was odd or even. No, we learned that all the odd functions are reflected, no, over the origin, are reflected over the origin, and will be something like that. They made like a saddle here and then continue in this way. No, and that is an odd function, but it's a positive. No, it's a positive odd function. And then if you have a negative odd function, we learn that all negative odd functions will rise in the left and they will fall in the right. And the shape of the negative odd function will come this way, will like a saddle here, and go this way. So that is the two options that we have. And we know that this function is a positive. Then the behavior of this function will be this one, that will fall in the left and rise in the right. So let me erase the negative. So that is the behavior. We already know what is the behavior of the M function. And why it's so important? Because we know that our graph don't have to be specific like this one. Let me keep it this one. But we know that our graph that we have to draw will fall in the left side or will come from negative infinitive, if you want to say that, and will rise in the right side or is going toward infinity. If we have already find out the degree and we find out the behavior, now we need to find the intercepts. So the second question that they are asking in this question number 1, I will have to make a line here. Now the second question is, or B, find the intercepts. To find intercepts, you can go back to the original equation that we give you in the beginning of this question. F of x is equal to x squared, no, times x minus 6, because there's the two factors that you got when you factor the equation x cubic minus 6x squared. To find, as we learned before, no, we need to do this, we need to find the zeros of the polynomial. How you find the zeros of the polynomial, or how you can find the value of the x in this polynomial, the values of x, and you need to set to 0 these two factors. So let's set these factors to 0. X squared is equal to 0. Because it's to the second power, I can square root the x squared, and my index will cancel the power because are opposite equations. But remember, before, always when you square the left side, you have to also square the right side. But before square the right side, always you put plus and minus, and then you have to put the square root of 0. Again, because the index of the square root cancel the quadratic exponent, we end here with the x only, and here will be plus minus the square root of 0 is 0. But we know that 0 is neither positive nor negative. 0 is 0. So the answer will be x is equal to 0. And this would be my first zero of polynomial. X is equal to 0, my first value for x in this polynomial. So now let's set up also to 0 the second factor. The second factor is x minus 6. So you have a x minus 6 is equal to 0. We add 6 to both sides, and we ended that x is equal to 6. So that is also the second value. That is my second value for the value of x. Why is it important to find the zeros of the polynomial? Because these numbers also is the places where the graph will cross or bounce, will cross or touch the x-axis. Again, I'll repeat, the zeros of the polynomial or the values of x in this equation or in this graph also is the places where the line is touching or crossing the x-axis. Well, how you know that? Well, to find out, you need to find the multiplicity of these values. Then let's go back to the original equation again to find the multiplicity, no? See, find the multiplicity of the zeros of the polynomial. And again, I repeat again, the zeros of the polynomial is no other thing to find the values of x in this equation, but also is the places where the graph is touching or crossing the x-axis. So if we write my equation again, my original equation, f of x is equal to x squared times x minus 6. We know already, as we did in the beginning of this question, that the degree of the first factor is 2, and the degree of the second factor is 1. We know that all quadratic equations No, I'm talking about the parent functions that we never went through a transformation. All the parent functions for a quadratic equation. A quadratic equation is y is equal to x squared. You know, all these, and by the way, it's an even function. Let's talk about even and odd better. We know that all the lines of the graph of the equation for all the even function, because you can have a x squared or x to the 4 or x to the 6 or x to the 8, any even number, they never, they never, this line never cross the x. They touch the x and bounce because it's a parabola. This guy can here this way, touch the x and bounce again. That will happen with an even function. And we know, and also because these functions are reflected over the y-axis. Now that is your x and that is your y-axis. But also we know when we talk about odd functions, that is all even. All odd functions, that is, that is your y and that is your x, no? And I will give you example of an odd function, no? Y is equal to x cubic, or x to the 1, or x to the 5. All these are odd, no? And the even will be y is equal to x to the 4, for example. No, that are odd, even functions and odd functions. And we know that the line of the graph of the equation of all even odd functions will be reflective. I will put the positive one over the origin, 0, 0. That is the origin, the 0, 0. And we know that all odd lines will cross the x-axis, and all the even functions will touch and bounce over the x-axis. And that will help to us to answer the next question, because we know the multiplicity. We know that the even function is degree 2, and the first factor is a degree 2, and the second factor is a degree 1. That means that the first x, when x is 0, this one, the line of the graph, will touch only, will touch the x-axis. But because the second factor, x minus 6, is an odd function, we know that when x is 6, the line will cross the x-axis. And you see in the graph in the bottom, no? This cubic function is going, make like a saddle around the origin, and don't keep going up. It's crossing the x-axis when x is 0. No, but in the graph can cross the x-axis in different places. So the essence is that all even will only touch, all even function will touch and bounce over the x-axis, and all the odd functions, will cross the x-axis. And that almost answered every question in this assignment. And try to explain and do this graph in order you can understand. The last thing we need to do to graph our equation, because we already have all the information that we need to graph our equation, I would love to do a table of values. That is my x, that is my input, and my output is f of x is equal to x squared and x minus 6. So what we do is we input numbers for x. Remember, what is a function? What we learned in the beginning of, in the unit number 2 of this semester, we learned that a function is a relationship between an input and an output. And when we did also functions, intro to functions, we learned that if you input a value for x, you should get only one value for y. See, and we learned that the x was the independent variable and the y was the dependent variable because the answer of y will depend on what you input for x. So let's do a table of values. You put a -1 and you change every x in this equation for -1, the answer will be -7. If you set a 0 and you replace the values of x in the equation for 0, you will get a 0 for y. If you input a 1 for x and you replace every x in this equation by 1, the output for y will be -5. If you input a 2, you get as an output for y -16. Oh, you have a negative already, a -16. If you input a 4 for x, you get a -32. And if you input a 6 for x, you get a 0. And if you get a 7, you get a 49. And you can see, again, you can see the places where, as we algebraically all found, that the line of the graph will touch, no, will touch when x is 0 and will cross when x is 6. Again, the line of the graph will touch and bounce the x-axis when x is 0 and y is 0 in the origin, and will cross the x-axis when x is 6 and y is 0. So again, you have all the information here. You have the behavior of the graph, you have the places where the graph will go, and let's then do let's graph the graph. Then I will have to raise the second part of this equation or this problem in order to be able to graph. Let me see if I put the graph in the last part. If you can compare every information that we put before. So let me change my to black again, and let me put here my x and y. That is my y-axis, and that is my x-axis. And let's put some ticks, some values, no, for, let's put a -7. Let's put a negative. We have 0. You know that 0 is right here. That is your 0, 0, your origin. So that will be a -1. And that is the only negative that we have for x. Then we have a 1. We have a 2. we have a 4, we have a 6. Let me extend this arm of the x-axis a little more. And we have a 7. And I will put the values only because only the board is not enough. Even if we try to use the whole board, will be enough, but I give you an idea what's going on. And then we have the y values. You have let me fix this stuff. So the first y value that we have is 0. The second is -5. -5. The next one is -7. And the next one is -16. And the next one is -32. I will use the green color to do my line. So my first point that I have for this line is my 0. Well, it's -1, -7. That is the first point of my graph. The second one is 0, 0. The next one will be 1, -5 right there. My next one is 2, -16 right there. And then my next one is 4, -32 right there. And then the next one is 6, 0. And the last one will be 7, 49. I will put this right here. So you can see, and I'll use the red to follow these lines. So it's the graph according to this table of values. And remember what we predict here in the beginning. We said here in the beginning that the graph, we said that the graph will fall in the left and will rise in the right. And that is exactly what this graph is following in. Let's try to do one smooth graph without raise my hand. Sorry, I miss. I miss a point. Let's do it again. The graph comes from the bottom. It touch the 0, go down here and go up to this point. That is my graph. And you can see the graph is obeying what we determined in the beginning. The graph is falling in the left and is rising in the right, as we find out when we found the behavior of the graph. And that is the graph. That is the question number 1. The last question that we'll ask in this assignment is about turning points. And we learned that a turning point is, if I ask you right now, see where this graph is increasing, you said, well, Mr. Camacho come from negative infinity and stop to increase right now in 0, 0. No, stop in 0, 0. And then from 0, 0 beginning to decrease and go down until 4, -32 is decreasing there. and then it's increasing up, no? It's increasing up until is to infinity, because it's going to infinity. And that is the places where the place where the graph stop to increase and start decreasing will be these places, and then the other place will be this one, because here the graph comes from negative infinity to 0, 0, and at this point the graph stopped to increase and beginning to decrease, and is decreasing until they go to 4, negative 32, and at this point the graph stopped to decrease and beginning to increase again. In the places where the graph stop to increase and start decreasing, or stop decreasing and start increasing, these places are called the turning points. And if I ask you how many turning points we have here, you say, well, I only see 2 black points, Mr. Camacho, or I see 0, 0, and 4, negative 32. And that is true. We have only 2 turning points in this graph. And that is the last question of this assignment, how many turning points you have. Another way to find the turning points is when you find the degree, remember the degree is an exponent. When we learned from the beginning of this semester that an exponent have the form of a times x to the n power. So this n is always the exponent. And we know that 3 is the exponent because you added the exponent 2 plus the exponent 1 and you get exponent 3. And when you FOIL or you use the distribution property for multiplication and the factors, you ended with the exponent 3, and that is your n. So there is a formula to find how many turning points, and the formula is n, the degree of the function minus 1. So if the degree of the function is a third degree, as we found in the beginning, is a third degree, you replace the n by 3, you subtract 1, and the answer is 2. And it's the same conclusion that we got after follow the graph. There is only 2 turning points, these black dots in the graph. So you can use the formula to find how many turning points, or will be the degree of the polynomial minus 1, or you can follow your graph as we did first of all and find where the turning points are. And the turning points in the graph again is where the line stops to decrease or increase and start decreasing or increasing. Well, that is question number 1. Now let's go to question number 2. And the reason I try to go slow and explain everything is because you have these questions in the exam number 3. And you have to apply everything that you have learned in this unit and in previous units too. It's a lot of recalling. So I will encourage you to go and review factorization because we are doing a lot of factorization. I will encourage you to go to review polynomials, and what is a polynomial and everything. Then you will be able to apply all the recalling to this assignment and also to your mini review and then to the exam number 3. So let me erase everything. I'm done recording so you can go back and forth, rewind, forward that, stop the video. And also I am publishing my lecture notes in Blackboard. So you have in Blackboard the lecture note for this assignment plus my video. So let me erase everything and let's go to question number 2. Question number 2. In question number 2, they are giving to you another, as question number 2. Let me change colors. They're giving another equation in factor form. F of x is equal to 5 times x minus 3. No, x plus 3, sorry. X plus 3 times x minus 2 to the third power. So again, no, the first thing that we need to do when we do this kind of equation is we need to determine the behavior of this function. But before we determine the behavior of the function, we need to find out what is the degree of the function. Because again, you know that the second factor, x minus 2, have a degree 3. And the second factor, x plus 3, don't have any degree. And we said that when they don't give you any degree, you can assume that degree is 1. And also, the first factor have also degree 1. And if you, no, sorry, that don't have any degree because a constant. Sorry for that. It's a 0. That have a 0. So if you add these degrees, 1 plus 3, you get that the degree of the whole polynomial is 4. And 4 means it's an even function. You know, another way to do that, as we already said, another way to do that is to multiply the whole polynomial. No, you have a f of x is equal to 5 times x plus 3, no, and then you have a x minus 2 to the third. We can still have half of the board. So what we do is we need to first of all work the second term, because you have to multiply 3 times x to the third power. And if you multiply, that will be equal. Let me move the f of x a little to here. And that is equal to, say, 5. And you have still your x plus 3. But now you have a x. I'm going to put a bracket here. You have a x. Let me do more clear. I'll put my bracket, and I will put a x minus 2, and a x minus 2, and a x minus 2. I need to multiply these 3 together, because that is x minus 2 to the third power. And if we do that, we have that f of x is equal. I will put the whole number. I encourage you to do the multiplication, but for the sake of time, I will go straight to the answer. And the answer is a polynomial. You have a x cubic minus 6x squared plus 12x minus 8. No, and then if you multiply, no, if you multiply all together, no, you will get as a final result, f of x is equal to negative, and it's a negative. I never see negative in the beginning, but it's a negative 5 there. Sorry for that. Negative 5, negative 5, negative 5. It's a negative 5 x to the 4th power plus 15 x to the 3rd power plus 30 x to the 2nd power minus 140 x minus plus 120. That is the answer. But one thing that we can see is that the degree of this whole polynomial is 4, because that is the greatest. No, and this is in standard form. This last x is to the 1 power, and the constant, the one standalone, is the 0 power. So you can see that this answer, that the degree of the polynomial is 4 degree, also line up what we found here, adding the degrees of the both factors. So there's two ways you can find out what is the degree of polynomial. Also, we know it's an odd, but not only we know it's an odd, now we know it's an odd, it's an even function. Not only we know that it's an even, but we know that it's a negative even function. If we want to know how negative even functions behave, we need to do our graph. I'll put like two graphs I put before for the odd function, I'll put two graphs for that is your x and your y, and that is your x and your y for the even function. And let's see that is a positive even function and that is a negative even function. So we know that all positive even functions, all without exception, will always be up, up. And we know that all the negative even functions will be down, down, because the even function, regardless it's a x to the 4 or x to the 2nd power or x to the 6th power, are parabolas. All are parabolas. And we know the parabola will touch and bounce over the x-axis. And if there's a negative, the same way will touch and bounce over the x-axis. And that is the two behaviors of an even function, a positive first of all, and a negative. Well, we know that it's negative, so we can erase that, don't get confused. And we have already the end behavior. The end behavior is down, down. So we have so far, we found out the degree of the polynomial, and we found the behavior of the polynomial. Now we need to find the zeros of the polynomial, or the values of x in this equation, in order to find in what places this graph or this line will be touching or bouncing the x-axis. To do that, I want to go back to our original factor form equation. Original factor form was f of x is equal to -5 times x plus 3, and we know the degree is 1, and then the x -2, and we know the degree is 3. So what happened? We already talked about before the behavior of all even and odd functions. And I'll put again, all the this is your y and your x. I'll put here even, odd, and both will be positive, but we don't talk about what we need to know is the behavior, that's the regarded positive or negative. So we know that the behavior is that if it's a even positive, we know that will fall in the left and rise. Sorry, if there's an even, will rise in the left and rise in the right because it's a parabola. It's a parabola. Will touch and bounce. And then if that is a even function, will be because the out function is reflected over the y-axis, no, or it's symmetrical. Whatever you want to say, symmetrical. Let's put here symmetrical. It's symmetrical over the y-axis. But we know that all odd functions are symmetrical to the origin. So they will come here and they will do something like that. Let me be consistent. Let me put the blue line and we'll put the cap will be, all the odds are symmetrical to the origin. Symmetrical. To the origin. So the even are symmetrical to the y-axis, and we know that all the odds are symmetrical to the origin. Origin is this point 0, 0. Why is important? Because we already find out that the behavior of this function will be down because it's a negative even function. No, but when we try to find if the zeros of the polynomial, what are the zeros? Is when we need to put these 5, -5, and then x plus 3 and x -2 to 0. We need to set to 0. All the answers will be the zeros of the polynomial or the values of x or the places where the line is touching or crossing the x-axis. So we know already that the behavior of these factors, if they are odds, the behavior is that they will cross, because you can see all the odds, they cross the x-axis by the origin. And if the multiplicity or the degree of every factor is even, they will don't cross the x-axis, will touch and bounce. So let's put the equation again and let's find the multiplicity, and according to the multiplicity, we need to find if they bounce or they touch. So the original equation is f of x is equal to -5 x plus 3 to the 1 power that is odd, and x minus 2 to the third power that is odd. So we know that both that will cross, and this one will cross also the x-axis, because both are odd. And we know that odd lines will cross the x-axis. Even lines will touch and bounce. So after know this data, we need to set up all these factors to 0 to find the value of x. Why the value of x is important again? Because that is the place where the line will be crossing the x-axis. So first of all, you need to put -5, no, is equal to 0. And this, we cannot use this one because it's a false statement. It's a false statement because -5 will never be equal to 0. It's undeniable that it's one of the factors, but we cannot use this one to find the zeros of the polynomial or the places where the x will be crossing the x-axis because -5 will never be equal to 0. So let's try the other two factors. And again, the reason we cannot use it because it's a false statement. No, or you can say it isn't. Sorry for that. True. Let me. Any one of these two reasons isn't true or it's a false statement. But let's try the second factor. Our second factor is x plus 3 equals 0, and the next factor is x minus 2. So it's x plus 3 equals 0. If you subtract 3 from both sides, the answer is x is equal to -3. And then x minus 2 is equal to 0. Then we can say that you add 2 to both sides, x is equal to 2. So we have two values. We have two places when x is -3 and when x is 2. That is the two places where the line will cross the x-axis. That is the two places where the line will cross the x-axis. But again, we know that the behavior of this graph, is an upside down parabola because it's a negative even function. So the next step we need to find some points that we can add to this, equation to be able to graph. I will need to delete the first part of this equation, or of this. Let me see if I can delete only the top, so we can still using the bottom part. Yeah. We put here even. So we already find out what will happen with this graph. I want to do a table of values to give to us some points, that we can use in this graph. And I'll put here my x and my y. My x and my y. And what happened if I put a -4, let me replace y for the whole equation, is -5 x plus 3 to the 1 power, and then you have a x minus 2 to the third power. Because if you replace -4 for every x in this equation, you will get 1080 for y. You replace a -3, and we already predict. No, we are doing this algebraically now. No, we predict what will happen and where we find the zero, the polynomials. But now we're using the table of values to ratify what we already found in the last part that we're working here. No, when we found these zeros, that is the places where the line will cross, and will cross when -3, x is -3 and y is 0. Then when x is -2, y will be -320. Then when there has to be a -2. Yeah, there's a negative. The first one is a -2. When x is -4, y is -1080. When x is 3, y is 0. And then when x is -1, no, y will be -270. When x is 0, y will be a -120. When x is 1, y will be a -20. You can see there you can see there the point we're turning out, because it was coming down and then go back to 20, turn around. And then when x is 2, y is 0, that is the second place where the graph is crossing the x-axis. When x is 3, it says y is 30. So that is most of the points that we have right now. So we can do that is my x and that is my y. And I'll put some ticks only here that we need. Let me put the points where -3. That is -3. And then the other one that I need, 0.20. No, 1, -20. That is my 1. And I'll put -20 here. And then I have my 2, 0. Also, I have my 0, 0 point that is in oh no, it's -3, -3, 0, -2. Well, let's try to do this graph. I'll put my points in green, okay? In the exam, I don't expect that you will do a perfect graph, no. But what I expect that you can at least give me the main points and try to do the best in your ability. So that is the two x-intercepts, sorry. And let me put any other point I can. 120, no, right there. it's negative 20, sorry. But this graph is coming in this way. It's coming from here, and let me, it's coming from here, and we know that will end this way also. Because we already said right here that the end behavior will fall in the right and fall in the left, because it's an upside down parabola. It's when that is 3, and let me put one more point. 3 ferry, when is 3, this guy is 30. I'll put 30 right there. So this graph me do my right. The way that this graph is coming this way, is crossing. Let me see my table of values, negative 1 to 70. It's crossing is going this direction. I will try to do the main points because there is no way that we can something like this, and then they saddle right here and go exactly there. This is another point. The 3, negative 20. That is the way that this graph is going. You know, yeah, that is the way that this graph is going. And you can see, you know, it's following the pattern down, down, is falling in the left and falling in the right. And I use 3 points to try to figure out how to graph this graph. But again, you know, you will have to do your best. I don't ask you to, let's put it in this way. If you give me the most closer points, you know, and your graph is crossing where they have to cross, no, I will give you the point. No, because you already found the zeros, you know it's a down, down. No, I try to give the shape that all these values I put in this table have, but if you cannot do it by your own, it's okay. Don't worry. But give me the best shape. Well, that is question number, and turning points, no? Again, turning points. Now, to do the turning points, you use the formula, no? N minus 1. N represent the degree of this function. We find out the degree, you add the 1 plus 3 is a 4, you know? So it's the degree is, would be 3 minus, the N represent 4, minus 1 is 3. And that is, we can call this place and this place. That is the three, I'll put in black. The three turning points. If you go to Desmos and you find the Desmos graphic calculator, and you put this equation in factor form, or the equation that we found in the whole polynomial, Desmos will graph for you probably in a better way than I did this line of this function, and you will see clearly, because you can amplify, you can reduce, and you can see the three turning points. They're very clear. But that is question number 2. Let's go to question number 3. Question number 3 is another polynomial. Question number 3. And in question number 3, they give you a polynomial, and you have to factor the polynomial and find, after factor the polynomial, you will have to find the zeros of the polynomial. Before factor the polynomial, you can use the equation in standard form to find out what is the degree and have idea how this line will behave, or this function. It's f of x, question number 4 is f. Remember, in your assignment, you will see the same kind of question, different numbers, by the same kind of equation. Only the number will vary. 121x minus x cubic. Please look in this equation. You know that there are two x's, and the first x, the value, because they don't have a exponent, we can assume that the exponent is 1. And the second term in this polynomial, the first variable, don't have an exponent, and we can assume it's 1. But the second term, the variable half exponent is 3. And you can see that 3 is greater than 1, then the degree of this polynomial is 3. So you can say the degree of the polynomial is third degree. And not only it's important to know the degree, but you know that 3 is an odd. It's an odd function. And you know that odd functions, you have two options, no? I will put the negative first and the positive this time for the sake of the example. No, that is your y, that is your x, your y, and your x. And you know, to all odd functions, all without exception, no, if it's negative, we know that will rise in the left and fall in the right. And if it's positive, will fall in the right and rise in the left. We know that. We went over this over and over, and I will give you a generic shape of this function. Come this way, and this one will come the same way. So that is the negative odd, and that is the positive odd function. And to find out, or to see more clear, let's put this equation in standard form, because right now it's not in standard form. When you put the equation in standard form, you put the power from increasing in a decreasing form. So you go from the bigger to the lesser. So that is equal to, say, f of x is equal. I need to put the 3 in the front and the sign of the 3 is negative. If you keep the sign of every term, you are not changing the equation. And the sign of the first term is positive. So after you do that, you can see that it's a negative odd function because you have a negative sign in front of the whole function. So the graph that we are looking for is this one. So we erase the positive. Oh, sorry, I did the wrong erasing. I need to erase the negative, the positive. I erase the negative. That is the y, that is the x. Let me do it again. Sorry for that. No, the behavior of a odd, no, they fall, they rise in the left and fall in the right. And I'll give the generic shape of these equations. There's a generic but can change because the polynomial goes this way. So I will erase the positive because it's not the case. We are dealing with an odd negative function. And that is the behavior of the function. The end behavior is will rise in the left, the whole graph, and will fall in the right. So now to find the places where the line is crossing. And why is it crossing? Well, we need to find the factors to know where cross and where bounds. So to do that, we need to factorize this equation. So the first step I need to do to factorize this equation is the first technique that we'll use is taking out the GCF, the great common factor. And you can see that both equations have an x. So if I try to factor an x from both equations, and I factor, let me change colors. I can factor an x because both factors have an x, and x can divide evenly both terms. And remember there's a 1 to the 1 power, there's another 1. So when you say, and there's a negative x, it's a negative 1. So when you have a negative, sorry for that, let me do this again because it don't look very clear. Try to negative 1x cubic. Yeah, that's better. So if you have a negative 1 and a negative 1, you get a positive. You divide two negative, you get a positive. And then you subtract 3 minus 1 is a 2. It's a positive x squared. And then you have a positive 121. Positive 121 divided by negative 1. Positive and negatives are negative. You get a negative 121. And the x of 121, the variable is to the power of 1. And the one that we have taken out as a great common factor also have the power of 1. And 1 minus 1 is 0. They cancel out. So that is the answer. No, the answer is, and I would take the 1 negative x times x squared minus 121. That is your factors, your two factors. My question is, what is the, we cannot stop there because what we have inside of the parentheses, you can remember when we were doing factorization, that is a special product. Inside the parentheses, we have a difference of two squares because you can take the square root of 2 and you can take the square root of negative or 121. And because it's a difference of two squares, we put a negative x outside always. We put the parentheses and we can put two parentheses because when you have a difference of two squares, you can do the shortcut. What is the square root of x squared? Is x, and I put an x in every parenthesis. And what is the square root of 121? The square root of 121 is 11. And I'll put 11 in each parenthesis. We know that the first parenthesis must to be positive, and the second negative. Now we have finally our final product, and that is the same equation that we start, x cubic plus negative x cubic plus 121x, but now is in factor form. If we FOIL these factors and multiply together, we will end back again with this original equation. And what is the multiplicity or the exponent of the first x, the one is outside of the parentheses? That is, this factor have a multiplicity of exponent 1. You can see the next two parentheses don't have any exponent, and we say that if they don't give you exponent, you can assume that it's 1, 2. And then the only thing we have to do is add this together. 1 plus 1 plus 1 is 3. No, 1 plus 1 plus 1 is equal to 3. That will be the degree. And that match also the degree here and here. So we know that we have the right factors and the right multiplicity. But now we can find out also where the zeros, no? The first zero will be that negative x is equal to 0. Then the second one, x plus 11 is equal to 0. If you subtract 11 from both sides, the final answer is that x is equal to negative 11. And then the third factor is x minus 11 equals, let me do again, x minus 11 equals 0. And if you add 11 to both sides, you know that x will be equal to 11. So it's my first zero, or the first place where my graph will cross the x-axis is when x is 0. Then, and the multiplicity is 1. That means will not only, but will cross. Because remember what I said, if the multiplicity is even, no, we know that all even is will touch only and bounce. But the multiplicity, the exponent is odd. All the odd functions cross the x-axis. So it's the first place where the line will cross the x-axis, or not the first place, but one of the place is when x is 0, will cross. Then the second one, the second factor, that is when x is negative 11, we know that the multiplicity is 1, 2 is odd. Also, when x is equal to negative 11, the line will cross the x-axis. The last factor, no, when x is 11, also have a multiplicity of 1, and then the graph will cross also again the x-axis when x is 11. So we found so far the degree, we found the end behavior, we found the zeros, we found the zeros, and we found the multiplicity, and we found that in the 3 zeros, let me change color. Sorry. We find out that the zeros of the polynomial when x is 0, comma, when x, let's put in order, when x is negative 11, because negative 11 is before 0, when x is 0, and when x is equal to 11, no, in all these places, no, we can say that the line of the graph will cross, and the three places will cross the x-axis. So we have a lot of information. We know the places. We can do a table of values too, to help us. Let me do a little table of values. Let me do in this part. Let's put a table of values here. I will put all I can because we don't have a lot of space. When x is negative 12, y will be 23,436. When x is negative 7, y will be 0. Try to find out something before keep writing numbers. Yeah, that is not very accurate. We put the most important points. When x is 0, y will be 0. When, let me put this point, let me put -1 because it's important. When it's -1, will be 138. And then when it's 0, will be 0. When it's 1, will be 192. When it's 3, that don't make sense. Let me do something different because let's do this again. You have your x and your y. When y is -11, y will be 0 because that is one of the places it's crossing. When x is 0, y will be 0. And then when x is 11, y will be 0 too. And that is the main place where this graph is touching. And let me try to do the graph here. I have when you go to my lecture notes, you will see the graph there. Let me do this again. Put that as your y-axis, your x-axis, and let's put some values here. I will put the -11. That is your 0, 0. That is your 0, 0. And that is your 11. And we know already, because the behavior of the line, we know that the graph will rise in the left and will fall in the right. We already find out from the beginning the behavior of this line. So let me put my line in red. Let me put another number here. I put two extreme numbers I found. Let's put, let me see how I divide it, 450, 500, 475. and I will put here 400, negative 460, and here we'll put positive 450. So let me do the line, and that looks is when it's around 5. Let's I'll put 5 here. And that looks is when is -3. -3, right there. Okay, so I'll do the best to graph this, but again, I put the graph already in my lecture notes. You can go and see it. See, this line is coming this way. It's crossing exactly right there. That is my first zero, no? When x is -11. It's going down until -3, 460. Then it's coming up again and it's crossing at 0, 0. We have the other 0 there. And then go all the way until 5, around 5 and 450. And then it's coming back again and it's crossing at 11. And you can see it's following the behavior that we already figured out in the beginning. This graph is rising in the left and falling in the right. Another thing that we need to know, and it's very important because that will reflect how accurate we went in our predictions and in our equations. We have 2 turning points. You see, the line is decreasing and stop to decrease and start increasing at this black point that I just put here. And then the line increase, and when they get this second point, the line stop to increase and start decreasing. And that is called the turning points, no? So we can predict, look in the graph, that we have 2 turning points. But we can use the formula. Now, the formula that we use in the first 2 equations is that n minus 1 is equal to turning points. Well, we know that the n is referred to this number, to the degree, the highest power is your n, the degree of the polynomial. And the degree of these polynomials is 3. So if you go 3 minus 1 is equal to. And that matches exactly what we found in the graph. There is only 2 turning points in this graph. Well, I hope you enjoyed this assignment as I enjoyed it. Take your time. Again, we are recording. You can go back and forth. You can stop the video. And you can, when I put all my lecture notes in Blackboard are downloadable, means you can download this to your computer, and if you have a printer in your home, you can print my lecture notes and you can compare what is in the lecture notes, what is in the video, complement together, and do your assignment. The next Monday, we will be doing rational functions, and probably I'll combine 2 together, rational functions and system of linear equations. And then by Wednesday, we should be reviewing for exam number 3, and we can start the exam number 3 Friday. I will keep open from Friday to Monday, and you have the whole weekend to practice. The practice test number 3 will be also available on Friday. You can practice 10 times, And every time they will give you a grade, this grade is not going against your overall average. It's only to let you know where you are. Another thing is important is remember exams are 70% of your grade, or final grade, or mid grade, or weekly grade. You need to work. You cannot miss exam. So you need to prepare yourself. I give you all the tools for the exam. If you have any questions about anything that we've done today or the weeks before, or we're doing Monday, please shoot me an email and I will happily answer and help you in your concern. One more thing, if you need help, I can tutor you face to face here in the classroom, or we can use technology via Zoom. I can tutor you too. The only thing that you will hear is my voice, and you will see this big screen that you see with all these numbers, and I will see through the speakers of the classroom, I will hear your voice. And we can go through any problem that you have questions in order that you can be ready for exam number 3. Also, Cal Arbor State College have purchased a free, you have a free account in tutor.com. No, and to do that, you need to go to Blackboard, start here, and roll down until you find tutor.com, click there and follow the instructions. And you can be tutored by tutor.com at any time. You are working and it's 3 o'clock in the morning and you want to be tutored, somebody for tutor.com will be ready to tutor you at 3 o'clock in the morning. I can tutor you face to face wherever you can, or also via Zoom. So guys, you have the ball in your court. Start working, start studying. Don't drop the ball. We are almost close to the end. You need to end strong. Well, God bless all. Don't forget to go to church Sunday, and I will see you in the next video.